Back to our channel. In this today's lecture, we are going to talk about RDDs, data frames, and datasets, and what are the big differences between these three, and why we prefer data frames rather than datasets and RDD. Let's get into the lecture. First, RDD. RDD is nothing but a resilient distributed dataset. Here, in the name itself, it is saying that resilient. Resilient means fault tolerance. The RDD, if RDD fails while running the job, and then automatically Spark recomputes by applying same transformation in the previous RDD. So the RDD is automatically restored from its original from its previous RDD by applying the same transformations using the lineage graph. And second one is distributed. Distributed means when we load the data into the Spark, then in the form of RDDs, the data will be loaded. Means data RDD is the basic building block of the Spark. So again in the RDD, the data is divided into partitions. In the Spark, default number of partitions are 4. We can increase or decrease the number of partitions based on our requirement. So finally, what we understood, when we load the data into the Spark, then the data will be stored as RDDs. And again, the data in the RDD, the data again stored in the form of partitions. Each partition having 128 MB of data. This is called distribution. And RDD has some features like immutability, lazy evolution, fault tolerance. We already discussed what is fault tolerance. It can prune the it has a minimal number of transformations are available to apply on top of the data, and it doesn't use any type of performance related engines to enhance the performance. It is using low level language. And next one is DataFrames. Currently we are using DataFrames. DataFrames is also same like distributed as like RDD, but here the data is organized into a named columns. Means when we load the data in the RDDs, we cannot specify the names there, and if we want to specify the schema in the RDD, we have to use case classes in Scala, and explicitly we need to convert RDD to data frames, and we need to impose the schema on top of it, and then again we have to convert data frame to RDD. It's a lengthy process. But in the data frames, here the case is different. The data itself organized into a named columns. It is similar like a table in the database, I mean MySQL database or Oracle or something. It is fully schema based, and it uses Catalyst engine and Tungsten optimizer to enable the performance of data frames. And it supports column level operations. Optimized because it uses Catalyst and Tungsten optimizers. Now let's get into data sets. Dataset is strongly typed and distributed collection of data introduced in Spark 1.6. It, com- it combines the best of RDDs and data frames. So when we write the code in RDDs, it is completely type safe. Means you can catch the address in your code while typing. But in data frames, you can't find it is not type safe. It throws errors in the runtime. Okay, but here the datasets is also strongly type safe. Means you can find the errors while writing the code, and along with that, it uses Catalyst and Tungsten optimizers. It is a component. It takes two different best types from both data sets, data frames as well as RDDs. But the main limitation is datasets is only available in Scala and Java. It doesn't support Python language, and it uses encoders. and also it's also immutable and it is optimized. Let's see what are the main differences between these three and why we prefer data frames over data sets and RDDs. The first point is when we consider language support, uh, RDD supports any every language, but here the thing is RDD is not optimized, right? So we are excluding from this competition. Okay, datasets, but datasets is only supports Scala and Java, doesn't support Python. But DataFrame supports four different languages: Scala, Java, Python, R. Along with that, it supports SQL also. Second one, performance. Even datasets also good in performance use because it uses Catalyst and Tungsten Optimizer. But Catalyst Optimizer performs better with the data frames rather than the datasets. Because when we use datasets, its performance is completely rely on encoders. Means datasets use encoders to convert JVM objects into Spark optimized format. So it becomes overhead when it's doing serialization. So it is little bit slower than the data frame when you compare the performance between these two. And next one is simplicity. Data frames are simple. Why? Because even Python is so simple to write and easy to use. But datasets doesn't support Python. This is one thing. And second thing is it supports SQL also. And next one is serialization overhead. This is already we covered in the performance coin. Now let's get into the hands-on. Before going to write the code for the RDD, first we need to import the Spark session, and then we need to initialize Spark variable. And now I'm importing Spark session from pyspark.sql, import Spark session, and Spark equals to Spark session dot builder dot app name and get or create. Now let's try to create RDD1. Here we already discussed that RDDs are low-level language, so we need Spark context to create RDDs. We use parallelize keyword. We in later lectures we deep dive into what is parallelize and all. Now RDD1 is created, and then here I'm mentioning one function. Whenever it meets 5, it should raise an exception. Here I want to check the fault tolerance of Spark. So I'm simulated failure forcefully to check the tolerance and retry policies of Spark. So if ix equals to 5, then it should raise exception. The job has failed. Otherwise, it should return x multiplication of 2. Then I'll try to apply this function using map transformation. Example, failure. And then I'm trying to collect the results using collect. Let's try to keep this collection in try-catch block so that it tries to collect the data. If it not, it tries an exception there. RDD2.collect except exception as e print e. Now let's try to run this job. The job should fail. Let's run this. Why it is getting failure? Spark session. It's running. The job has failed, and it is failed with exception. The job has failed. If you see here. Let's get in deep dive into the Spark UI. Here here the DAG is showing that only one parallelize function we have used. It shows like that. And our job has failed, right? So that here the status is failed. Let's get into the stages. Here, if you see that 3 by 4 means the data is divided into 4 partitions and 3 has successfully completed, 1 has failed. We can't sure that we specified nearly 6 to 8 numbers, but here we are not sure which number is belong to which partition. So totally 3 partitions are succeeded, only 1 has failed. If you see that stages, for first 3, here see that we specified 6 values. Whenever the x equals to 5, then only it should fail. Here if you see that 3 partitions successfully ran, but when it tries to run the 4th partition, it has failed for the first time. And if you observe the attempts, it tried for next 3 more attempts. Again, still it has failed. So here you can decide that Spark is fault tolerant. And here the retry policies are 4. It tried for 4 times and it has failed 4 times because 5 is occurred. And you can check time duration of each and every partition. And if you see the DAG in stages, we created two different RDDs, right? One is for creating first RDD using parallelize, and second one is creating by applying map function on top of RDD1 map. So second RDD is directly depends on the first RDD. This is called immutability, means we can't change the existing RDD. It creates new RDD every time when we apply the transformations. And we go into the storage. We didn't store anything, right? So shows zeros. And environment. Here you can find the Spark properties. Here you can see the retry policy also. Here retry limit is 6 and retry items are 10 here mentioned. And next one, executors. Here if you observe the executor summary, the total successfully completed tasks are 3 because 3 partitions are successfully ran. 4th partition has failed, right? And it retries for 3 more times. So total 4 times it retried, but again it has failed. So failed tasks are 4. So the total tasks are 7. And you can find task time for each task times to run the entire process. Total number of, here I'm using single node cluster, so only one activated node. So total nodes. These are the things we can observe from the Spark UI. Next, let's try to apply the transformation by multiplying each element in the RDD with 2. And then map lambda x2 and collect. Here you can observe the output. Each number and the RDD is multiplied by 2. Next, let's start DataFrames. So first we need to specify the data. We need to create the data with some names and IDs. First column should be name and second column should be ID. By using create data frame, we can create the data from data equals to data and schema equals to data. We can use show to show the data frame. Yeah, here this table like structure you can find. And then to display the data in the form of Excel, you can use display. Then automatically it displayed in a nice format, Excel format. Next, you can convert data frame to RDD by giving .rdd, so that try to show the RDD. It should throw an error. Yeah, it throws an error like RDD object has no attribute show. So we need to collect the data. Here you get the output. And then RDD4 equals to, let's apply transformations on top of this RDD. We know that few transformations are not available in the data frames, which are available in the RDD. So if you want to apply those transformations, we need to convert data frame to RDD. Instead of writing the entire code in the RDD, if you write like that, we'll lose optimizations, right? So better to convert our data frame to RDD at that point, and we can, after applying that transformation, we again revert back to our change from RDD to data frame. Here, if you see that after applying transformations, name and IDs are swapped. Now let's bring back our data frame from RDD using 2DF, and we can specify show here. If you see that we lost column names because this is derived from RDD, right? So we need to explicitly include schema while applying 2DF inside the 2DF. So now schema. Now we got name and ID names of the data. Likewise, we can do both type of transfers by vice versa. In the upcoming lectures, we'll deep dive into Y transformations, different types of transformations, and different types of optimizations. Everything we'll discuss in our later lectures. Thank you. So here we can use DataFrames over the datasets. And next one is community and ecosystem. We already know that most of the machine learning libraries, graph frames, and third-party APIs are already written in the Python. It is very easy to use and access using Python, using DataFrames, because DataFrames are also we can write in Python, right?